So why are we all here? Carbon dioxide in the atmosphere is today at 415 parts per million. We all know that is way too high, and it continues to go up. Yet we continue to build in the knowledge that we are contributing to that carbon dioxide when we do that. We call these emissions embodied carbon, which is a somewhat elusive term, I think. Some governments around the world are finally taking note and starting to tackle this, but only a handful. And we're yet to make any real progress in reducing embodied carbon. So today we're joined by some brilliant speakers who are going to break this problem down for us. First, we've got Kat Scott, who is Sustainability and Regenerative Design Manager at DRMM and a steering group member, Architects Claire, and a Circular Economy Coordinator at LETI. And she was also part of the group that kind of founded ACAN in the summer of 2019. And so she's involved, very heavily involved. Brilliant to have her here. Then we've got Yannick Giesekum after that, who is from the University of Strathclyde. He spoke recently to Parliament at an Environmental Audit Committee inquiry into the sustainability of the built environment. So we're very lucky to have him here. Following that, we've got Andrew Waugh from Waugh Thistleton Architects, who are some of the leaders in low carbon architecture through their use of timber. So we're going to hear a bit about their work and about their research into policy. And then we've got Anne-Marie Fallon, who will be joining us remotely, and she's practice leader at Archetypes Edinburgh office. So without further ado, I'm going to pass straight over to Kat. I'm going to pass you this microphone, Kat. So the microphone isn't amplifying in the space, but it is recording online.
Thank you, Joe. And hello, nice to be here in real life. So yeah, Joe's given me enough of an introduction, so I won't talk any more about myself. But first, I think it's worth just clarifying, when we're talking about carbon today, what do we mean by carbon? And often you'll see it look like this with a little E next to carbon. And really, when we're talking about carbon, we're meaning a common unit for greenhouse gases. So we're not just talking about carbon, we're talking all greenhouse gases. And we're talking about all of these together, and they're measured in such a way that they are comparable in terms of carbon. So I just wanted to clear that up before I just keep using the term carbon throughout my talk. We all know the scale of the problem and the amount of change that is needed. And at the moment, the recent IPCC report this year flagged how our current policy scenario is putting us on track for an above 1.5 degree future scenario. And even with significant improvements to the current policy scenario, it's looking like it's increasingly risky that we might be above the 1.5 degree range. So the rapid scale of decarbonisation that we need to make is really, really vast. And that's why it's so important that we're here in Glasgow for COP26. Just to give you a flavour of what the WWF think a 1.5 degree world versus a 2 degree world looks like, either way, it's going to be pretty shit. There's going to be more extreme weather instances in both scenarios. People will be more affected in both scenarios, but obviously the 1.5 degrees scenario is preferable on kind of all counts. So anything that we do beyond 1.5 degrees of global warming is just going to make bad situation worse. So we really need to be doing everything we can, and the best time to do that is now, because cumulative emissions make the problem much, much worse if we act slowly. In terms of a global picture, the UK historically is responsible for a really significant amount of the global amount of cumulative carbon emissions that have been created. And also, if we look at a global picture in terms of equality and inequality, the poorest 50% of people are only responsible for around 10% of total lifestyle consumption emissions, and it's the richest 10% who are responsible for almost 50% of global carbon emissions. So we, as people living in a rich, comfortable lifestyle in the UK, compared to the rest of the world, we have a huge responsibility to do what we can to improve this situation and help those who have less than we do to benefit from future growth and change in their countries. The built environment, I'm sure you've seen this graph a million times, but the built environment is responsible for around 40% of global warming, global carbon emissions, with 28% coming from building operations and 11% coming from building materials and construction, which we'll be talking about today, of course. The UK GBC have set out 3 definitions for net zero, net zero carbon in terms of construction, net zero carbon in terms of operational energy, and then whole life net zero carbon. You need to be really careful when you hear people talking about delivering net zero to really challenge what scope are you measuring? Are you talking about just operational, just the energy that your building's using? Or are you talking about construction products, the actual embodied carbon that goes into making buildings? And are you talking about end of life of your building and the maintenance and repair that goes into it? We can't just be looking at a small portion of carbon now, we need to be looking at everything. So in 2019, Architects Declare was founded, and I think this was a turning point for our industry in terms of understanding and platforming embodied and whole life carbon as an issue. And I've put in bold here all of the declaration points that kind of allude to that. And Nettie's Embodied Carbon Primer was released in 2020, of which I was one of the authors. And this was, again, another kind of landmark piece of guidance, which I think has really created a step change in knowledge in our industry. And what we set out was that basically, as the grid decarbonizes and as our buildings get better and better in terms of fabric performance, as they must, what tends to happen and what will happen is that as the operational carbon, the energy that we use to heat our buildings and keep them running and lighted, as soon as that starts to reduce because we're using energy more efficiently and the grid's decarbonizing anyway, then embodied carbon becomes a really big portion of the pie of carbon emissions. And as that circle gets smaller and smaller, that will become the bigger and bigger portion, and of which most of that increased slice of the pie is coming from the upfront embodied carbon associated with the materials and how we construct our buildings. So whole life carbon, there are industry agreed standards on how we measure embodied carbon, and I hope you're familiar with this, which is the kind of whole life assessment metric, if you like, matrix. So everything in this area here is upfront carbon. So that's everything that happens before your building's even had its front door key opened. And then everything in this orange box is embodied carbon. So upfront is part of embodied, but they're not the same terms. And embodied carbon includes everything up to the end of life of the building, while whole life carbon encompasses that, as well as the operational carbon. And for infrastructure, it also incorporates user carbon, I think, which there's emerging standards coming forward. The tricky area is module D, and this is where we're talking about circular economy and the kind of post-buildings life system benefits. So if you're familiar with cradle to gate and cradle to grave, this is a kind of illustration of how that fits. So this is an embodied carbon diagram which grew from the Letty work, and this was an update done by ACAN, just showing how, when and where these kind of carbon spikes happen. And as I said, a really big chunk of the carbon in our buildings arises before you've even moved in, before practical completion. You've got a huge chunk of carbon. And while over a building's whole life, there then are smaller spikes of maintenance and replacement of cladding or replacement of windows, there's also quite significant operational carbon, which we hope that over time is going to reduce anyhow because of the decarbonisation of the grid. We tend to work, when we're talking about embodied carbon and whole life carbon, we tend to work with a lifetime of 60 years. Obviously, we'd hope that our buildings last far longer than 60 years, and I hope that in 60 years' time, we're not demolishing that many buildings. So here, I think ACAN are alluding to that. And then at end of life, there's a big question mark of how reusable, how repurposable are our buildings. This is from the Architects Declare recent practice guide, which came out, I think, a week ago. And it illustrates kind of the scale of our impacts as architects. So these bubbles here show the size of an average global person's footprint, 4.8 tons of CO2. And in the UK, our footprint is about 3 times larger. These are the sizes of kind of illustrative business operations for architecture practices. So for a small practice and for a large practice, we're talking about almost 10 times the small person here. And then we go up to project impact. And as soon as you start to work on large projects with large floor square area, we're getting to really, really large circles that they hardly even fit on the page. And it just goes to show that in our profession, we have a huge, huge potential to reduce carbon through the work that we do. And I think that's a real privilege, and it's something that we all really need to take and really work with. So where do embodied carbon impacts arise? I'm just going to go through that diagram and break it down for you. So the product stage, A1 to A3, everything that happens in the supply chain to produce your material. So here I've got cement and steel just because they're really easy to show how many processes go in. You've got the vehicles moving around and doing quarrying and transporting materials. You've got heat generation to produce the materials. All of these energy kind of forms add up to create an embodied carbon that ends up how you made your material that you see before you. So this concrete here went through all of these things in order to be here. And that's what we mean about embodied carbon. And most of that on those pages are fossil fuel driven at the moment. Embodied carbon impacts then in A1, A4 to A5, we're talking about on-site and transporting those materials to site, and then the processes of constructing our buildings. So kind of any waste generated through that process, that would count in here. And also just how much energy it takes to construct our buildings, whether that's vehicles driving around in petrol and diesel vans or whatnot. Then in use, we're talking about maintenance and repair of our building fabric. So like I said, replacement of windows is a good example, or replacement of cladding after like 20 years perhaps. But also the process of cleaning and maintaining our buildings. And this is from Cool House's House Life, which I'd really recommend that you watch, about a cleaner maintaining a really architectural house. But it's worth bearing in mind that over a whole life, these kind of seemingly small impacts can really, really add up. So every time you paint a wall again, that small amount of carbon over a whole building's life will really, really add up. So this diagram at the bottom here is from Letty, a group in Letty. It's not a published diagram yet, but just showing how actually over the whole life of the building, interior finishes and kind of cleaning can end up being a really significant part of the whole life carbon picture. And then we're talking about end of life in module D. At the moment, we have a very linear economy, and this is where there's a really big tension and overlap between embodied carbon and whole life carbon and circular economy. And Letty are about to publish a paper kind of exploring this in much more detail in the next few weeks. Also, on the diagram at the bottom, you'll have noticed that there's a sequestered carbon box. Over a whole life, there is opportunity to sequester carbon and kind of explore the idea of carbon positive or carbon negative or whatever language you want to use. This diagram here is from a research paper on carbon sequestration and storage in the built environment, which is a really, really worthwhile read. And it demonstrates how over a whole life of materials, how there's a difference between cementitious materials and their kind of life journey with carbon, where there's a big carbon burp, but then over their life, they kind of slowly carbonate and react with carbon dioxide in the atmosphere and sort of sequester it back into the structure. While biogenic materials such as timber, straw, hemp, they start out life with, by the time they're on construction site, with quite a large amount of sequestered carbon. And then slowly over their life, they may release some of that carbon back into the atmosphere. And the big question for those materials is then what happens in module D and kind of end of life scenario. Do we keep those buildings in place for hundreds of years, in which case that's locked away, that's great, or do we send them to a landfill where they're likely to be incinerated, where they'll release a lot of carbon? That's a big question mark, which I'm sure Andrew will touch on. At the moment, we produce a huge amount of the UK's waste, and we reuse very, very few construction materials after their first life. And we're just producing more and more waste. So this is a huge issue that we need to address. There's loads of embodied carbon material out there. These are kind of some of the examples where you can look for industry agreed methodology. So for us, it's probably worth looking at the REBA's embodied and whole life carbon assessment for architects. But essentially the fundamental calculation is you're calculating how much stuff have you designed, the kind of carbon impact per unit of that stuff, and timesing them together, and you get the environmental impact of your building in terms of carbon. And you'll find online lots of different sources for embodied carbon statistics for different materials. A good source for those is the ICE database, which is generic data, which is really well researched. But this is a visual illustration, which I'm sure some of you will have seen, which is material pyramid en.dk. And it just really visually shows you the kind of different embodied impacts of different materials on a singular basis. But the best source of data, once you're in the process of designing a building, is to talk to suppliers and get EPDs for the materials and products that you're specifying, and then go through and look at what their life cycle impacts are. These don't just look at global warming potential, by the way, but at the moment, that's kind of mostly what we're relying on as an industry. This is one for Vasta and timber. But there are also tools that make the job a lot easier for you emerging, and quite a lot of really good free ones. So the top tool here is HBERT, which was developed by Hawkins Brown, and the bottom tool is by Field and Bradley Studios. So this one's Revit based, really good if you've already got your model in Revit. So you might be kind of at a later design stage maybe. This one's really good for really early stage testing in an Excel format. So they're kind of different tools emerging and coming forward, and there's lots available. But when do your decisions matter most? Really, the earlier decisions about should we even build this building, that's where you make the biggest carbon impact. And as soon as you start moving through the design stages, once you set your form, your volume, your heights of your buildings, your spans, then you're locking in carbon impact. And it gets very difficult through the later design stages to really improve the carbon picture much. You make a narrower and narrower scope of improvement for yourself, especially when you're on site. It's too late, you can substitute the odd material. So it's really important to be thinking about this from day one on any design project. On the whole, I'd say have a look at the Leti Embodied Carbon primer. There's really useful diagrams like this where you can start to break down for different typologies of buildings what the likely proportions of different impacts are. And what we tend to do in our office is then multiply these by benchmarks that are available to give us a target for, say, facade, and work to that in our office and develop options that work. And yeah, so there's lots of really practical guidance out there. On the whole, if you can build less and build light, you're doing a really good job and getting going. And then it's all about building wise and trying to really improve big ticket items, which I'll show you in a sec. So for example, in a normal building, your upper floors, your foundation and your envelope, really big ticket items, and there's huge potential for you to reduce the embodied carbon in these components. And if you can engage with your whole design team, your structural engineers, particularly in the early design stages, to explore options that will reduce this, then you're on really good progress to reduce the embodied carbon. Like I said, that's not to say that the internal finishes and kind of smaller components don't matter, because over a whole life picture, they really, really do matter. And if you're able to eliminate anything at all, and make, for example, self-finishing materials used to limit the need for extra internal finishes, then that's a really good step as well. And so, for example, the cork house is an example of where the structure is acting as the final finish, and you've eliminated a layer of stuff. And for example, this is our Sky Health and Fitness Centre that was designed by DRMM. And again, you see that the timber is acting as the final finish. There's nothing concealing the MEP work. We've left it all exposed, and it's as minimal as you can be in terms of the amount of layers of stuff in a building. And that's what we want to see. We want to see materials working really hard to do many things: structure, aesthetics, shading, whatever. We want to be doing as many things with as little stuff as possible. And tall buildings, it gets really hard to limit your embodied carbon. Once you get beyond 12 stories, you're a bit stuck really, and you start to see really extreme diminishing returns in terms of what you can do. Saying that, timber is potentially a solution for taller buildings. And here's an example of a project that we did in London that's a tallish building in CLT. Unfortunately, legislation is making that difficult at the moment. It's also really important that we're not just talking about timber. We all use concrete, even those of us in the room who are designing in timber, we have concrete foundations. So we need to be engaging with what's the best practice for concrete. And this is from the Concrete Centre, a really useful piece of guidance showing you how you can reduce your embodied carbon impact through sensible specification of cement alternatives. And we should be finding ways to use existing materials. So here's an example that was published last week in Reba J, showing how existing concrete can be repurposed to make new structures that are ultra low carbon. And the best thing you can do is just not knock buildings down. We should be doing more retrofit and retaining existing structures. And that's probably one of the lowest carbon things that you can do. You've probably seen the REBA benchmarks. It's really important for us all to be working towards these and also feeding back data to this so that the REBA can keep improving it. Leti have a rating badge system, which we've recently launched, which helps to visualize how good is my building. So this has kind of got a close relationship back with those REBA targets. And Bennett's Associates, so I think the first practice who've actually done this, have measured their building's impacts on 2 projects against the Leti benchmarks and been really open and transparent with how they're doing. I think we all need to be a lot more transparent about how we're doing, even if actually the outcome isn't what we want to see. So this is the kind of Leti input form to do the benchmarking exercise. And like I said, we need to be really careful with the language that we use, otherwise we're at risk of greenwashing and misleading people. It's very confusing, but it's worth looking at this diagram, which just explains when you can say different things. Am I talking about net zero in design? I've designed it to be net zero, but actually when the contractors on site, are they going to build it exactly how I've designed it? Is it quite going to go to plan? Or are we talking about net zero actually being what happened on site? And so there's a whole range of guidance in the LETI carbon alignment page on their website. But just to say, we're not just in a climate crisis that's created by carbon, we're in a real ecological crisis. This is from the Stockholm Resilience Centre illustrating the great acceleration. And although correlation does not necessarily mean causation, in this case, they're demonstrating that over the last 50, 60 years, we've seen an acceleration in all of our consumption. And this has really impacted nature in many numerous ways, not just carbon. And we also now have more man-made materials on Earth than there is natural flora and fauna. We've got so much stuff. So I urge you to please try find ways of using what's already here rather than making new stuff. Because we're also at risk of using up finite resources. You know, we can decarbonize concrete, but we're also running out of sand. We're using it at such a rate that nature can't replenish it anymore at the rate that we're using it, and it's a depleting resource. And also our electrification of our society relies on materials like lithium, which again are rare and finite sources, and the extraction processes for those are not always positive. This is in Bolivia, and you see the scale of impact on the landscape. So we really need to be thinking about going beyond net neutral and not bad, and moving towards trying to be actually really good in how we design. So I urge you, when you're thinking about embodied carbon, to still be thinking about how to make buildings for nature. So this, I think, by Sarah Wigglesworth Architects, is a good example of a low embodied carbon system, which is more than just a facade. It's also home for nature to live and thrive. And we can also start to think at a system level about how nature feeds into the carbon system. So thinking about how we're designing for street trees and for green roofs, and the carbon sequestration that they're able to create and contribute to our systems in cities. But we need to be really careful when we're talking about introducing, for example, green roofs, that we're conscious of the playoff between embodied carbon and regenerative benefits. If we're starting to plant trees on buildings, think about the impact that that's going to have on your structural design. We've got some tricky tensions in play here, and I think it's just really worth engaging with them on every project and seeing what the best thing you can do is. Personally, I think trees are probably best left in the ground, but that's just my view. And also just to remember that our climate is changing. There's no use us designing buildings now that in 30 years can't tolerate the heat. We need to be designing to future weather files, and we need to be designing to consider how people will keep cool and how people will actually live and work in our cities. Otherwise, we're at risk of, again, building redundancy into a system that's already flawed enough as it is. So yeah, I think that's me done. Thank you very much. Give you the mic back.
Putting the end back on the microphone. Okay, great. Thanks, Kat. That was fantastic. I'm just going to change the slides over, and next up we've got Yannick. But I thought a fantastic slide that Kat showed was the one that demonstrates the scale of the problem of a project's carbon compared to your personal carbon footprint. So when you try and change things in your personal life, it's very important, but next to the carbon of a building, it's really not very consequential. So if we have amazing agency as people that make buildings and the built environment to reduce the impact of that. So thanks, Kat. Okay.
Still getting the slide ready. Welcome to Glasgow, everyone who's not from here. Should take this off, shouldn't I? As a Glaswegian, it's really great to see so many people come to the city, and I hope you've all had a good time so far. The presentation I'm about to do is much like most of the COP preparations, a little bit last minute and less polished than it should be. But I have at least, had time to make sure and took the rubbish out of it. So we'll see how this goes. Do I need to hold that?
Yeah, so I'm going to pin this onto you. So just to give a bit more of an introduction to Yannick. So he's, as I said, he's from the University of Strathclyde, just around the corner here. And he presented recently to government, well, to Parliament on this very issue. Yannick is also one of the authors of Part Z, which some of you will have probably seen, which is a proposal for a new building regulation to tackle embodied carbon. So yeah, very glad to have you here today. I'm going to pass this to you. You can clip it on wherever you like.
Right, is that going to be screen all the time? Needs
Yeah,
to be higher. Okay, I'll shove it here. Right, is that all right? Grand. Okay, cool. Apologies in advance if you're in the room and you've got, honestly, to anyone who's watching this on the camera, it is sunny in Glasgow, and so the slides are very difficult to see at the moment. If you find me on Twitter or my website, you can download the slides from there just now. So if you want to look at them on your phone or later on. So Joe's asked me to talk about two things essentially here: scale and the policy response. So I'm going to start all the way from the very global level in billions of tons and go all the way down to 1 ton of embodied carbon. And I'll be taking through, what's happening at a national scale, what's happening at a more local scale on the way. Back to that thing about how big's a project compared to a person's impact and so on. And then I'll talk a little bit about what some of the other countries are doing in policy terms on this and what's happening in the UK at the moment. So it all has to start way back with this at the Paris Agreement back at COP21. What that did was obviously set in train the whole chain of events that have brought us to Glasgow so far. An agreement to limit global warming below 2 degrees, pursuing efforts to 1.5 as it was at the time. And it set up this ratchet mechanism, which was designed to essentially have a 5-year stock take of how all the nations in the world were going on their nationally determined contributions, which were basically sort of volunteered set by each nation of actions that they were going to take and targets. Glasgow is the first real test of this ratchet mechanism. Back when we were finishing Paris, we were well on track for beyond 3 degrees with the nationally determined contributions at the time. Since then, we've had a little bit over 50% of global emissions coverage has had strengthened NDCs in the interim period before Glasgow even started. And of course, we're here on the Wednesday of the first week of COP, and we've already had a number of new announcements from the likes of India and Nigeria. And I'll talk a little bit later on about what those add up to. That ratchet mechanism, though, this is the kind of progression I was talking about before the COP. So this is the UN basically synthesize all the contributions that have been made. So back when we had Paris, we were essentially on track to be up here in this gray zone. So this was emissions out to 2030 based on what we were committing to then. So continuing to increase at a fairly substantial tick, just less so than it would have done otherwise. By the time we got to the start of the COP, we were now down into this blue zone. Now we'll be probably more like here-ish based on the last couple of commitments. So you can see that really over that near-term next decade, all we're really committing to do is some very marginal reductions in total global emissions. What we have, though, when you zoom out to the longer term, though, is this huge gap you can see between the nationally determined contributions up here and the kinds of pathways we need to be on to get down to 2 degrees or 1.5 degrees. And all of the commitments that we've been seeing are things around 2050, 2060, 2070 net zero targets. So there is still this huge gap in terms of near-term action that we need to close. And that's one of the key things that we're talking about over the next 2 weeks. Longer term, though, the good news from a lot of the commitments that have been brought forward in the last couple of days. So this analysis that's on screen here was done prior to the COP. There was an updated version that was published this morning, which I didn't have time to add into the slides yet. The updated version published this morning by a different group who do the same sorts of analysis suggested that actually the long-term targets that we've come forward with now, if you assume a sort of fairly optimistic interpretation about everybody fulfills all of them, and the trajectory that you assume along that, what that looks like, that's actually down now to about 1.9 degrees. So this is the first time where we've had a set of global commitments that notionally could bring that 2-degree goal back into play. And that's as of this morning. Now, obviously, there's still a huge challenge in delivering all of those reductions, delivering upon all of those targets and so on. But that's how far we've moved in those 6 years since Paris. The big challenge, though, as I said, is closing that near-term gap, getting us back down onto those pathways over the next decade or so. Kat mentioned, you had this slide up from the year before's version of this report. So every year, the Global Alliance for Buildings and Construction publish a kind of annual progress report on the built environment sector using data from the International Energy Agency. So every time you hear someone in a presentation say, you know, the built environment's 40% of emissions or embodied carbon's 10% of emissions, it's almost always drawing from whatever the latest version of this report is, or sometimes the version from 5 years ago. This is the latest one that's just come out for 2021, which covers the first sort of COVID affected period. And you can actually see here, these two chunks are the two construction bits. So what we might think of as embodied carbon, closer to 20% of global emissions last year, partly due to reductions in emissions from some other sectors because people weren't moving around as much and so on in the pandemic. And partly because we did actually globally carry on building an awful lot of stuff during that period. The one thing I would say is anytime you see somebody say that 10% figure, always think about what that includes, because historically this bit here has basically included the impact of material production. It hasn't included things like the impact of transporting all those materials to site and so on. So 10% is really a lower bound, really you're talking about 20%. So that was a global picture. UK, what are we talking about? Well, this is the last 20 years of data. These slides have all been messed up.
Sorry, yes, we...
have you dumped them into some other presentation?
Sorry.
Right, okay. So yeah, download the ones online and look at how they're supposed to look. So last 20 years, the trend is still the same of emissions for the UK, bobbled about above or below about 50 million tons of carbon dioxide equivalent each year. What's actually underlying that is two trends. So what we have is essentially increases in what we're building and reductions in the carbon intensity of the supply chain, so the production of the materials and so on. And there's a couple of interesting things to point out with these two competing trends that have left us on a sort of broadly flat overall trend. And that's essentially the global financial crisis, which we had the worst and fourth worst annual drops in construction output in the UK on record in the space of a very short period of time there. That was the only period really where we actually made any substantial reductions in our total embodied carbon, because quite simply we stopped building. Since then, we've had construction output returning back up towards where it was before, so back building again, and we've had a slowing of the improvements in the carbon intensities of supply chain. Because back in the 90s and the early 2000s, there was lots of easy stuff you could do, you know, taking coal off the grid, the kinds of transformations we saw in the cement industry back in that period. Now we're having much more gradual, slower gains in the carbon intensity. So going forward, you've got to do one of two things. You either have to massively accelerate the reduction in the carbon intensity of supply chains, and there's lots of discussion at the moment about all the different technologies in terms of carbon capture and storage and hydrogen steel and so on that might do that. But you also have to think about how much are we going to be building in the future, because it's those two things that are really going to determine what trend this follows going forward. Just to give you a sort of sense from, like, you know, a ton all the way up. So 1 ton of embodied carbon in the UK at the moment will probably get you about 4 pallets of bricks. So I've assumed if you turned up to an event like this, you know what a pallet of bricks looks like. That's 1 ton, so keep that in your head. That's for UK average bricks at the moment. By the time you get to like 10 tons or 100 tons, you're probably talking about 1 very large house or 2 small green ones. By the time you're working your way up towards hundreds of tons or 1,000 tons, you're probably talking about small to mid-sized or particularly green commercial developments. For example, Kat mentioned this great new timber sports hall that Venice done. That 709 tons CO2 upfront carbon sequesters 638 of that in the timber. So you can see the kind of scale of potential benefit there if you want to include that. Once you get beyond, you know, 1,000 tons, 10,000 tons, etc., you're talking about quite large commercial developments. So for instance, here's 5 Broadgate, if anyone's familiar with that. More like 50,000 tons of CO2 upfront to practical completion there. And if you're working for a client organization, you might be talking beyond that in terms of your pipeline. So for instance, Landsec have started recently publishing what the estimated embodied carbon of their development pipeline is, which I really applaud them for doing. But there you're talking, you know, a couple 100,000 tons of embodied carbon in their next 6 developments. And so that's the sort of, you know, scale that you can influence if you're working in this industry. If you work on infrastructure assets, oh, sorry, this little blue dot is kind of like what Kat was saying before of, if I lived twice as carbon intensive a lifestyle as I do, and nobody decarbonized any of those activities in the future, and I live to be 100, which as a Glaswegian male is statistically very unlikely, then that is maybe where at the worst case scenario I could get my personal carbon footprint to. So almost everything you're working on will be an order of magnitude or more bigger. And if you work on infrastructure, that scale really starts at 10,000 tons and goes up from there. So, you know, 100,000 tons probably get you a couple of miles of motorway with a junction at either end. By the time you get to 1 million tons, you're talking about the biggest road building project in the UK in the last few years. Beyond 1 million tons, a few million tons might get you a third runway at Heathrow. And if you go past 10 million tons, you're really only talking about mega projects like HS2. So that's your kind of top end of the spectrum in terms of carbon scale. So obviously we're talking about some big numbers here, millions of tons for projects, etc., 50 million tons for the UK, etc. What are we doing about it on the policy side? Well, this, entirely illegible to anyone in the room, but you can download the slides afterwards, slide is a summary of all the kinds of policies that different European countries are bringing in to start to address embodied carbon through building regulations and other means. And what we're essentially going to see over the next 5 years is this enormous natural experiment whereby lots of different countries are bringing in slightly different requirements with different methodologies, different approaches to reducing this. And they're all going to play out simultaneously. And we're going to try and find out, okay, which of these works, which one actually drives down embodied carbon the fastest. But what you don't see on this slide at the moment is the UK. And I'll come back to the UK in a second. The general approach that these European countries are taking is essentially come up with some sort of roadmap at the start, give a bit of clarity to the industry on what's going to happen going forward, and say, okay, from this date, we're going to require you to report your embodied carbon on all your projects, or all your projects above a certain size. On those projects, we'll ask for you to report against a standard methodology. We'll give you tools to do this. We will give you a national database. We will give you a national methodology, etc. You follow those. Once we've gathered that data for a period of time, typically that seems to be a few years, then we'll start setting limits based on that data that's returned to us. And we'll say your building has to be below this many kilograms of CO2e per square meter, etc. And that whole process of development, from first kind of saying we're going to take action on this through to setting limits and so on, that's going to be a multi-year process for all of these kinds of countries. The Dutch have kind of already done it, but they're sort of the outlier in terms of having cracked on with this a decade ago. The US, by contrast, have taken a totally different approach. So they've basically been going down this kind of buy clean, public procurement-led approach to reducing embodied carbon. That all really kicked off with the Buy Clean California Act back in 2017, which really set in place this precedent of saying, okay, if you're going to work on a publicly funded project, we need you to bring forward environmental product declarations for each of these materials that you're using on it, showing that they're below a limit that's set by a public body. And that's the sort of general principle of it. Now, what's happening at the moment in the States is there's lots of different variations of this coming forward within different states. So for instance, in Colorado, they've now passed one which covers more materials, slightly different approaches for transport and other projects. There's various other states that are in the process of putting through things on this. And there is a federal bill that is up in front of committees at the moment trying to do the same at a national scale. If you want to know more about all these kinds of international regulations, so instead of 30 seconds with 2 big tables, I gave a presentation at the Institution of Structural Engineers Climate Emergency Conference recently, which talks exclusively about all these kinds of policies and so on. So you can have a look at that if you're interested. So what's happening in the UK? Well, we don't currently have this as part of regulations. What we do have is a set of different voluntary requirements that people have adopted and requirements for certain public sector bodies and so on. So back at the end of 2020, they brought out this new construction playbook that is now extending the requirements on whole life carbon assessment to social infrastructure projects. So if you work on kind of road or rail or whatever, you'll probably already have been doing these kinds of assessments for a few years. Now, if you're working on a school or a hospital or any of these kinds of things that qualify as social infrastructure, you will be expected to start doing these kinds of assessments routinely. Now, they're currently in the process of essentially rolling out all the different plans for different departments for how to implement this. So I imagine this will take some time, but in the long run, social infrastructure, economic infrastructure, you will be expected to do these assessments. The net zero strategy, which came out a couple of weeks ago, represents a little bit of a move forward, and it actually mentions embodied carbon. And it puts out this statement of essentially saying the government aims to support action in this, improving on reporting with a view to exploring a maximum level for new builds in the future. Now, there's no real specific timeline or actions for development of that in the strategy. There are some other bits that are relevant in terms of indicating some sorts of possible timelines that might be. For instance, there's a section talking about kind of demand side measures being brought in the late 2020s and so on. So you can read the tea leaves on those if you want, or you can have a look at that kind of Twitter thread for a summary of it. But it is a move forward. And that was backed up in their recent response to the Committee on Climate Change. So every year, sorry, that's a really old way of talking about it. The Climate Change Committee, I always forget they rebranded. Every year they submit a progress report to Parliament, which includes a bunch of specific recommendations to different departments. Every year for the last 3 years, they have said you should include embodied carbon and start measuring and reducing that. And you need the regulations in order to do that. Last year, the equivalent statement to this was essentially a fob off of saying, well, we would need a methodology to be able to do that, to which the response was, well, there's all the methodologies on Kat's slide before, the Rick's statement that's been there for 4 years, etc. This year, it was a really distinct evolution because it basically said, yeah, we expect to do something on this in the future. What that will be, what the timeline for that is at the moment remains unknown. One other bit that's, seeing as we're on Finance Day over at the COP, for anyone who's been down there earlier, the other bit that's potentially impactful here, and I'm really sorry, but all my slides have been messed up by this getting copied across by somebody. What this document, the Greening Finance Roadmap, set out, also launched alongside the net zero strategy, was the government's intention to bring forward these new economy-wide sustainability disclosure requirements. So this will affect all the kind of financiers in the UK. And the idea is that this is going to use a newly developed UK green taxonomy. So in a nutshell, that basically sets out what is a sustainable activity if you are a financier, what can I class as sustainable. The proposal for this is that it's basically going to essentially take what's in the EU version of this at the moment and then adapt that out, and we'll have a UK one. Now, the EU taxonomy earlier this year introduced whole life carbon assessments for the largest schemes into their taxonomy. So that's now part of what the European equivalent model for this is. First quarter of next year, we will find out whether the UK is going to do the same or not, because they will have to make a decision as to whether to copy across those requirements. So keep your eyes peeled out for that. I realize that's a very nerdy, specific kind of finance bit, but it might have quite significant implications in terms of the reporting requirements that stem from it. The heat and building strategy, after a lot of speculation and news paper articles and so on beforehand that it might include something on embodied carbon, did not have anything on embodied carbon in it. Unfortunately, it remains to be seen what will be done on that going forward. As Joe mentioned, at the moment, the Environmental Audit Committee has an ongoing inquiry about sustainability of the built environment, a big chunk of which is focused on embodied carbon. There's a whole load of evidence responses submitted. That arrow's moved with the thing. There's 4 evidence sessions that they've already got online that they've held. They're holding more in November. I would expect some recommendations from that to government in the early part of 2022. They'll be obliged to respond to those within 2 months of whenever those are produced. So that's the national picture. Meantime, some of the local authorities are cracking on and doing stuff. So London, the new plan that came out in March, has these new requirements for referable projects. So those are the largest categories of development. So what we'll have through that is basically a kind of 3-stage process for doing whole life carbon. Pre-application, you have a set of 16 principles that you're expected to sort of demonstrate qualitatively how you're incorporating those into your project. So it'll be like, oh, right, okay, circular economy stuff, etc. What are you doing on it on your project? And so the idea is it's just going to prompt you on these 16 different areas that we know will reduce embodied carbon if you act on them. Then you'll be asked to do a stage 1 quantitative submission. So that might be a stage 2, stage 3 design kind of version. And then you'll be asked to update that assessment post-construction and submit all of that data using a common template. Now, they haven't yet sort of taken a position on what they'll do with this data over time, but if they're following the same sort of model as all of those European countries I mentioned before, then you would assume over time you would use that data to then form the basis of limits for future projects. As Joe mentioned, if you think we should be including embodied carbon in building regulations, I strongly recommend you go to partzed.uk, where you can read a set of proposals that a group of us from the industry and, well, yeah, I will count myself as the industry, even though I'm an academic. Maybe I'm the token academic on this one. This is basically a set of proposals around exactly what the wording of the building regulations could look like, what an approved document would look like for it, and a whole lot of commentary that goes with it that sets out why we've written it like that. What we've been doing throughout this whole process since we launched this is gathering feedback from absolutely everybody who wants to speak to us about it. And I think I'd say the broad thing from that is this general consensus around this is a good thing to do. We should do it. We now have over 114 statements of support on the website from different companies, lots of household names, everything from SMEs up to, we've now added the UK's largest active asset manager. In the last week, we have several of the UK's top 10 contractors on there. We have statements of support from REBA, iStructE, CIBSE, etc., etc. So I think we can try and build a reasonable consensus about this, and we're having a kind of parliamentary launch bit of this the week after COP finishes. So the more support we can demonstrate at that and say, look, there is real widespread industry support for this, better. So please consider submitting a statement of support if you haven't already. 2 final quick plugs if you're around for the rest of this week or next week for the COP. The UK Green Building Council will be launching their net zero whole life carbon roadmap for the UK built environment on Thursday of next week, which obviously sets out a whole package of analysis and policy recommendations and so on, not just about embodied carbon, but also operational carbon and what we need to do about it. You can sign up to, it'll be getting streamed. It's in the Blue Zone if you want to attend it and you have a delegate pass for that. If not, I think you can stream it online. And tomorrow night, the UK Green Building Council are launching their Scottish kind of regional branch. So yeah, I'll be along at that and hopefully maybe see some of you there to talk about, you know, okay, could we do a Part Z for the Scottish regs, for instance? And, you know, could we get a group together to do it? So that's all from me. Like I say, download the slides and hopefully see them in a bit more detail. Thanks very much.
Okay. Great. Thanks a lot, Yannick. That was excellent. Really good to get a sense of the overall scale of the problem as well, and the size of some projects and Heathrow and HS2 and that kind of stuff. Really interesting. Okay, so next up we've got Andrew Waugh from Waugh Thistleton Architects. So you probably all know who Waugh Thistleton are. They built the first CLT building in the UK and they've done many since. They also have research projects looking into how to accelerate timber and policy for that as well. So in my work for the Timber Accelerator Hub for the ASBP, I've had the pleasure of working with Andrew recently because our projects kind of align. So very pleased to welcome Andrew here. And I'll just get up his slides and pass the microphone over to him. There you go.
Small. Thanks very much. They were such good presentations, guys. Thank you. I feel like kind of most of my slides, after the slides of these guys, most of my slides I'm just going to skip through. Frank, honestly. So, and I thought while I was listening to those two that what could I usefully add to what they've both said? And I guess that I talk to you from a perspective of practice, you know, how we're engaging these issues as a practice, and how we think about ourselves as a practice, you know, what we do and what our ambitions should be. And it's been kind of quite a journey for us as a practice. You know, I set up straight from college, and we designed, as Sarah remember, we designed kind of bars and restaurants and loft extensions and kind of, you know, and it just kind of gradually got bigger. And then we sort of became more and more engaged in what was going on in terms of the implications of the buildings that we were making and the buildings that we were designing and how we were designing those buildings. And protest and action and being vocal about these things has become an increasingly important part of how we practice. So this is us obviously pre-pandemic in full marching mode. And I'm also one of the steering group members of Architects Declare. And for me, selfishly, what that has done is really kind of helped me solidify some of the ideas, feel reassurance, I'm sure for lots of you who are in ACAN as well, that kind of, you know, having these opportunities to talk about these things, not just as an opportunity to kind of, for some sort of professional therapy, but also to kind of help, I guess, to invigorate, you know, your actions, to invigorate yourselves in these sorts of terms. Now, as a practice, I put this in the first book we wrote in 2009. As a practice, something that we started to do in 2008 after Murray Grove was to give out drawings. Was anybody who wants to know what we were doing or how we'd done it, we decided we didn't really know the term open source because the sources hadn't been invented then really. So, but we started sending drawings out, often, you know, in a brown envelope. And we've done the same ever since. So the notion of kind of open source and collaboration has become a real kind of, you know, what's that expression? Backprop, whatever, of the practice and of how we operate and how we work. And similarly, research has become, maybe I can pin this. Do you pin this? Yeah, then I kind of feel like sort of Elton John and all. So so research has become an increasingly important part of our practice as well. Now it's about a quarter of our turnover is just research-based and working for the European Union, for the US Department of Agriculture, with the Loudest Foundation, Built by Nature funds and others over the years. Wow, this is really, I quite like the font that you've invented for me. I just paid somebody £12,000 to choose me a font. So just kind of like, you know, as we start as a practice, you know, in terms of design, and it is for us, you know, as you can see from our work in timber, mostly about embodied carbon, but also from the start, it's about designing good buildings that understand their impact in terms of operational carbon as well. So that's about good passive design, low energy equipment, and renewable energy sources on site wherever possible. Now, those are just the kind of the basics of where we start every project. And then we talk to our clients about embodied carbon, and Kat showed a few diagrams, which I've already emailed you and asked you to send me. And this is one that we often use with clients and with politicians, which is to say, well, actually, if we build a building in 2021, 100% of that carbon is the materials in the construction process. And as time goes on, for the 60 years that we notionally give a building to live, then actually, you know, that 100% of the materials in a typical, this is for a project for 120 apartments, a 10-story project in concrete, that this would be over the years just under half the embodied carbon of the total carbon footprint of the building after 60 years. It's about 50-50, as I think that Yannick said. But if we take that back to 2040 and what we have to do by 2040, then in fact, about 2/3 of that building's impact are embodied carbon. So this is why it's so important to be thinking about the building materials and what we do. In fact, in that report, the -45 report by the 6 universities that have just got together, they talk about reducing our impacts by 2040 by 45%. Now, there are no magic inventions. There are no kind of, we can't just keep practicing as architects and hope somebody will invent something that reduces our responsibility. It means that by 2040, we need to reduce the amount of concrete we use by 45% across all of our projects, everything that we do, all the infrastructure and everything. Now, if you think about how long most of our projects take, and certainly for a big project in the office, say 5 or 6 years from the first phone call to the to the people moving in is a fairly typical time period. So this is happening to us right now, and so the kind of changes that we need to make as practices in practice need to happen. And we know that we're kind of up against it slightly as well. We know that the emissions of concrete, look, this is in the BBC and the Guardian, so it's all true. And we know that concrete is responsible, just the production of cement, responsible for about 9%. So the cement industry say, Greenpeace say it's more like 12% of carbon emissions just from the production of cement, which is about 4 times airline travel. Oh no, the worst one is gone. But so this is some of the things that the concrete industry puts out. So the Mineral Products Association, you have a multi-million-pound PR budget, which is why when a concrete building burns, timber gets banned. Yeah, so because they spend a lot on PR and they spend a lot lobbying our government and a lot lobbying industry. They used to sit in the front row whenever I did a talk, and they don't do that anymore. Not you, no. No, so and then kind of like and the sorts of embodied carbon targets that surround our industry, and sometimes it's quite it feels like there's so much information, and which one, where do you go, how do you decipher between all of these and breaking down these targets. So these are all the different targets that we have at the moment. Whether it's for commercial buildings, it's the RICS, the least ambitious, surprise, 1,000 kilos. Letty at 600 and 500, the RIBA 800 and 600, or the GLA at 1,600 and 1,300. There you go, you can just keep on building just as you are right now. Interesting to see what will happen to the GLA and their emergent policy, because they've just been made chair of C40 as of last week. Has that been announced? Not yet, maybe. So it has been announced. So they've been made chair of C40, and as chair of C40, they have to pledge to reduce embodied carbon by 50% from right now. So how they're going to do that, how they're going to actually bring that policy in, it's going to be quite exciting to see. Yeah. Yeah. I've been smiling at her. Yeah. Yeah. And how we get to net zero carbon as practices, just in terms of kind of the energy use targets and the embodied carbon targets of different buildings, is relatively it's becoming relatively clear. So I'm not going to skip past that. One of the interesting things, because Janet was talking about it just now, but one of the interesting things that we found just in the last 6 months is that in the European Union, I just copied this from the newspaper. In the European Union now, all the environmental and social governance reports are now legal and mandatory, which means that investment companies that have signed up to an ESG target, which is 78% of all investment funds globally have now signed up to ESG targets. So that means all the money that pays for all the buildings that we build is pretty much signed up to ESG targets. And now, as of last year, when you report your ESG target, it's a legal requirement to do that and to incorporate embodied carbon within that. So in the last 6 months, most of the new work that we've got as a practice hasn't come from developers. It's come directly from investors and from the investment market, who are not getting the buildings that they want from developers and contractors, and so are going direct to architectural practices to ask them to build the buildings that the funds actually require. Now, I think that's really quite interesting, quite exciting in terms of how policies, different policies in different places have implications that one might not necessarily kind of have foreseen. And in the UK government, on the 29th of October, this is right? On the 29th of October, actually has made this mandatory as well, and the first G20 nation to make mandatory reporting on ESG requirements law. So that's going to have big implications in the UK, especially as the majority of those investment funds actually are registered in the UK through UK banking. So we also record and discuss with our clients. This is a building that we have at the moment, which is a 6-story office building in Shoreditch, 5,000 square meters of timber. And in fact, interestingly, it represents about, you know, that big new machine in Iceland that they spent millions and millions of dollars on, which sucks up carbon dioxide from the atmosphere and buries it in the ground, 4,000 tons a year. That's 2 of these buildings. So, you know, by building it in timber. So this is the kind of, so these are the sort of calculations that we make as we go through. And this is kind of our own sort of in-house method of recording, which is kind of gleaned from both the Hawkins Brown one and from the Field and Clegg one as well, with bits of other pieces in it too. But lose over the years. So we reach this kind of equilibrium with storage of carbon. That's 70% of the volume of the tree. Now, when you cut down that tree and you make it into a building, you store that carbon of that tree in, you know, hopefully for more than 60 years. And you store that carbon in the tree. But can you count that carbon in that tree? Because it was already there. So just by cutting it down and owning it as a human, does that mean that you can count it? I don't think so. I think that if you use a tree from a managed and certified forest, then you have to grow 5 trees, 4 to 5 trees in its place. When you cut it down, you grow 4 to 5 trees in its place. So when those trees grow, then you have sequestration, because it's in a way it's an on-site offset. And so the other thing about sequestration is the more you count sequestration, the more it encourages you to use lots of timber. Because the more timber you use, less carbon you have. So it's a really tricky one, which I think that we need to get better at describing as an on-site offset. Yeah.
So now the question, I'm from a local authority.
Yeah.
When you ask them, can we remove the basement? For their care?
No.
Yeah.
But you know, they didn't. And we've got a spunking big basement.
Yeah. I mean, we're in a local authority where CSK are architects, and they're the ones who do the forecast. So
Right. Okay.
you know, they know what they're talking about.
Yeah.
And they fight all they don't fight on these people. But this is the issue, that these decent people who know exactly what they're talking about come up with brilliant schemes. Anna was planning into but they are fools who don't know what they're talking about, who are not.
No, I mean now we have a kind of, now, you know, when we make a pre-application for every building that we have where the client has asked us for a basement, we do 2 drawings at the very beginning, and we do 1 drawing of, in that instance, it would have been 7-story building with no basement, and a 6-story building with a basement. And our clients love it because obviously to build a basement is about 5 times the price to build a regular floor. But the local authorities still, you know, they anyway, so that's an ongoing conversation. But you know what? The more you say it, the more you illustrate it. It's quite a simple thing to do. It's quite a straightforward thing to do, just to show them this is the carbon here. This is a very quick way of saving the carbon. Even with the ridiculous building regulations regime that we have at the moment, you can still save a significant amount of carbon. You know, a basement and a reinforced concrete frame floor of the same size, the basement is about 5 times the intensity in terms of carbon of a regular floor.
It'd be really useful exploring on that to have some kind of simple guide for councillors, planners, so we can start to really influence.
Yeah, yeah, that's a great idea.
I mean, we're from we come from different parties, but it doesn't matter.
No.
We all have the same ambition in mind,
Good.
which is
There's lots of councillors who want to really push their council. I feel a diagram coming on.
happy to read it.
Yeah, absolutely. And I think, you know, and basements are really easy to win. You know, the other thing is that basements are bad for soil quality, they're bad for floodplains, they're bad for, you know, flood levels, all that kind of thing. So I think that a campaign against basements is a good idea.
Yeah.
They're horrid to work and live in. And also, people don't really put their bikes in them. I don't believe that they do. Certainly, anyway, so one of the things that we're involved in at the moment is building wood research program, which is a 10 million euro research program over 4 years. And excitingly, even though we left the European Union, we didn't leave the Horizon 2020 research program. So we are now the 27+1. So we are the +1, which sounds a bit too positive to me. But anyway, so we're involved in this 4-year program. And part of that is assessing policy and life cycle analysis. One of the things that the timber industry has really suffered from over the last few years is that they've all kind of sat on their laurels and not invested any money in life cycle analysis. While the concrete and the steel industry are having things like Steel Zero and talking about GGBS, which is a kind of GGBS, and talking about those things. And you know that if we use all the GGBS in the world, the vast majority of which is actually made in China, it's an aggregate with a cement replacement for concrete. So, you know what's the number one grain? Slag. Slag, sure. So if you use that, but even if you use all the GGBS that's available in China, you would only satisfy 15% of global concrete demand. So it's not a technology that's necessary. So we're working with the European Union to reappraise all the life cycle analysis of timber across the European market and the value chain at the moment. And part of that building wood is a whole kind of website and analysis, open source documentation, including work on basements and fire codes in all the 27 nations, +1. And structural systems, parametric models, all kind of like downloaded in Revit. And that will kind of be emerging in the next sort of year or so. And that research structure is working through kind of like, I've never seen this slide before this morning, so I can like to just read it through. You can see kind of like the open source will not only be kind of implicit to every region, how it's begun, described, how it's arrived at, and then work examples of where that's happened. So that will all be available online. In the UK, what we're doing with the Labs Foundation, we're built by Nature Fund, is we are designing what we're calling the new model building, which is a 6-story under 18-meter pre-warranty timber residential building, multi-story, multi-family residential building that we can build entirely in timber within current building regulations and pre-warranty by warranty providers, approved by the mortgage lenders, signed off by fire brigades and insurance agents. 21st of December. And will be complete and will be online as a completely open source document. It includes at the moment about 55 different different sections and details, each one of which can be applied to any shape or context of building for residential use for 18 meters. And those details can be drawn out really simply to understand what we need to do and then how we can go about doing it. So the idea of principle and then a worked example of each one of those details. Yes, and then all put together into one building. It looks a little bit like this at the moment. But then this morning, we were told by the warranty provider that they want the CLT roof to be pitched at 40%. So, but if it's in plywood, it only has to be pitched at 4%. But if you do a roof at 4% in plywood, you don't get the compartmentation between the parts.
That's what I was doing on the trains when he went to the night. 6 stories. Yeah. And then we've also, as part of that, we'll be doing a carbon target analysis as part of that work as well, which will demonstrate that without any sequestration, the new model building will be below the Letty 2030 target, substantially below. That's the line, and we'll see it. That's the other line, so we're below it. Will be below the Letty targets for construction. And although it's frustrating at 18 meters, while the whole of the rest of the world is changing their building codes to encourage timber buildings, Amsterdam announced yesterday that 30% of all government-funded buildings will be built from timber, where the GLA announced that they won't give out any grant to any building with timber in. We wrote straight back to GLA and said that includes windows. And they replied that they're not sure about that yet. And then we asked them if it included doors, and they said that they weren't sure about that yet either, or timber lintels over window openings, but they're not sure about that either. So, and then we asked them which experts that they had conferred with to arrive at this policy, and they weren't sure about that either. So I just wanted to talk to you about, so this is where we... I know, and we're on that journey, I hope, on that journey with them. But we did point out it's sort of, anyway, sort of Gove-ish sort of approach of policy without expertise. So this is a drawing that we enjoy in the office. This is the Garrett height theory, and this is about a journey through our career in timber. And what happens is, 2003, we had a technology trigger. My technology trigger was meeting a small Austrian gentleman in a kind of material centre between the sheet, wall insulation and hempcrete, and sat and chatted to him, which arrived at the building. And then that building went to sort of 2007, 2008, 2017, building big timber buildings, 600 buildings across the UK built from CLT, massive reductions in embodied carbon, and a peak of inflated expectation. And then we have had a change in building regulations. We lost most of the projects that we had in the office, and we are in a slow trough of disillusionment, which is where we're, what the hell are we doing? Why do we bother? Why do we try? But I can see this even now, this kind of slope of enlightenment that is beginning here in Glasgow, and this slope of enlightenment will take us as a practice to that plateau for which we cherish. Thank you.
Okay, thank you very much, Andrew. Okay, so we are going to go over to Anne-Marie Fallon now, who's dialing in remotely. Right, so dialing in from Edinburgh, we now have Anne-Marie Fallon from Archetype. And lots of you will know who Archetype are. So Archetype are one of the leading practices for sustainable architecture here in the UK. They've been doing it for years. They've built really low carbon buildings, both operationally and in terms of embodied carbon. Many of their office know how to do passive house design, which is really important, as you all know. And Anne-Marie is the practice leader for their Edinburgh office, and she's going to present now remotely. Over to you. Let's see if we can hear you.
Okay. Hi, everybody. I've just been really excited seeing people in real life presenting, so I felt like I was part of the room there, even though I'm coming in remotely, just with all the events that are on at the moment, and some practice work as well in the next couple of weeks. So I suppose the talks have gone really, really well in terms of the narrative of the layout and how we've approached the talking and challenges around carbon so far. So I want to build on where Andrew's left us in an amazing position. I really enjoyed Andrew's presentation and Yannick's and Kit's, obviously. And what I wanted to just go through briefly was 3 project examples of how we're implementing this carbon agenda and carbon awareness, and exactly as we were discussing earlier on from Kat, that the narrative around what we're talking about when we talk about carbon. So just a little bit of background on Archetype. We're a practice that are around for 37 years now, and really for the last 15 years or so, we've applied a passive house as our main energy methodology through the practice. And the reasons we've done that really, and that's how our Edinburgh office also evolved really, was from the coal reporting, the quality agenda in the public sector in Scotland, and again, some innovative local authorities in Scotland declaring the energy standards that they want to implement across their building stock, both retrofit and new build. We also operate a consultancy alongside the main architectural practice, Perform Plus, which focuses really quite a bit on aftercare of buildings, technical and thermal performance modelling, and material science, and soft landings and post-occupancy is a very big area for that as well. People have very kind of differing opinions on passive house, and there's a lot of myths and misconceptions out there. I think we've delivered over the years a variety of different typologies and diverse scales and ranges of projects that have plenty of proof in post-occupancy performance, which is really important to us. And again, hopefully illustrating here that it doesn't always have to be kind of big, boring, singular box. We do try and follow kind of form and function principles and try and bring a new kind of energy vernacular to the projects that we design, especially over the last 15 years or so. And a lot of that is underpinned by our own lessons learned from our own projects. So, the REBA Plan of Works and the Building Performance Network, there's new performance standards coming out there that are really emphasizing this. And I know it's not the focus of the talk today, but I think even from an embodied carbon perspective, as well as whole life carbon perspective, it's all very good that we talk the talk here. We need to be able to go back and actually evidence these buildings are actually hitting those carbon emissions, and that there's no slip in how those buildings are performing in operational and embodied carbon terms over their lifetime. So a tale of three. I was going to bring you through a new build timber frame project here in Edinburgh. A project we've completed for 6 years now, the Enterprise Centre, just a revisit of that project and the post-occupancy analysis and the whole life carbon analysis. And then our latest project, one of the biggest retrofit projects in the UK at the moment, to the ENERFIT standard in Cambridge, which also has a low embodied carbon brief requirement in relation to the materials that we're using for retrofit. And we see retrofit, as many have already mentioned today, being a huge area of growth in relating to actually getting to grips with what net zero carbon agenda and policies mean. And backing up all the speakers here, there's a huge disparity around how net zero carbon is interpreted, even in just operational energy terms. So hopefully some of the examples here, we can bring it through and illustrate a bit more of that. So my presentation is more about application of the kind of concepts and how we approach projects. And I think, we mustn't forget the position of the contractor and the supply chain in all our conversations around carbon. So everybody sitting in the room, as designers, as clients, you're passionate, you're having an awareness, ACAN, LETI, REBA, there's a huge awareness in the industry, but there's a huge knowledge gap in actually implementing a lot of this. So, we don't have too many Andrews in the UK or archetypes yet. And what we really need to see is, 100 archetype practices and, thousands of Andrews so that, this type of construction can actually be delivered. And this graph really just kind of illustrates simply to us where we begin when we try and actually start talking to clients about construction. And actually we talk about it in very practical terms, as well as the embodied carbon and whole life carbon impacts. And they have a reciprocal relationship. I mean, this is a very basic diagram here, but as we try to incorporate higher embodied carbon materials into super low energy, low embodied carbon, potentially buildings, whether that's retrofit or new build, we're creating a complete, increasing complexity, interface issues, thermal performance risk, air tightness risk, and delivery risk on the final quality of that product, of that building, as I said, be it retrofit or new build. And that has that kind of a proportional relationship to the increased amount of embodied carbon in the decisions that we make. So from a very early point, whether it's with a contractor or with a client, we're trying to help them, as has been illustrated as well with Walt Disson, a proper way of making these decisions early with the right stakeholders. So Maybury Primary School, the reason I'm showing you a Scottish project is because of the really ambitious agendas that have been set in Scotland, particularly by the Scottish Futures Trust around the public sector educational building assets. So in 2019, we were part of a consortium of consultants in Scotland that helped the Scottish Futures Trust establish a new operational energy metric. And very quickly on the back of that, with various other private sector consultant input as well, the net zero public sector building standard has grown, with several of our projects used as pathfinders for that standard, which is setting embodied carbon and whole life standards between 2025 and 2030 and mandating the requirements for them at their kind of city regional level. And all of this is obviously on the build up to these particular 2 weeks of this year with COP26 with yourselves over in Glasgow. So within that framework, the other policies that Scotland have been developing are around, and relate very much to a whole life carbon and embodied carbon agenda in relation to transforming the existing building stock, looking at low carbon energy systems, which Andrew's touched on, and really critically for us working in the public sector, delivering a resilient government estate. So what's important now about the existing building stock needs to be built on in the longevity terms for the next 60 to 100 years. So dealing with the new build angle first, this new energy metric is an outcomes-based metric. So local authorities in Scotland must deliver educational buildings to a condition rating of A, or very, very high quality. They must meet these energy targets. And this energy target is reported back, the metering operationally is reported back to Scottish Government over a rolling period of 25 years. And the funding for those projects is released on the basis of that performance. So it's a really powerful connection between outcomes-based funding being evidenced by operational carbon targets. And currently we're working, and there's various funding opportunities running out there to actually create a similar metric for whole life carbon emissions and holding clients and holding public buildings to account. So this is just an example of where a couple of our new build schools are sitting. And I just want to discuss briefly Maybury in particular. And part of the wider sustainability angle here is around where we're creating new buildings in Edinburgh City Council region or in other local authorities. We're trying to consolidate community assets. So it's not just a primary school, it's a nursery and an NHS surgery. And it's for a new development, Maybury, just southwest of Edinburgh on the way out to the airport. So, there's a little bit of consciousness around new build, awareness of how we need to consolidate assets and create very high quality buildings moving forward into the future. Another thing about whole life carbon or creating buildings that are built for adaptation and flexibility is that much of this school is built with open plan in mind. So future educational pedagogies, future functions or uses of this building have almost been pre-planned into the layout and section and plan to allow that flexibility and adaptability of use. Because again, Kat touched on it earlier, and Yannick, we can't continuously think, well, in 50 years' time, we're going to just demolish all the buildings we're building today and build a better functional building suitable for tomorrow's future. We need to build that future creation into buildings now. So it's a timber frame building. This is one of the pathway projects for the Net Zero Carbon's public sector building standard. I didn't come up with the name for that document, but hopefully someone comes up with a nice acronym so it can roll off the tongue. I think what it's done for us, and again, coming back to the supply chain and the contractual situation that we're in, and again, Andrew touched on this, is that we are working in an environment, particularly in Scotland, where at scale, large scale timber frame is not common. It's not a common approach. It's a very limited supply chain. And it's a big journey for the industry at the moment to really look at timber frame, looking at self-manufacturing and innovation to actually be able to start producing this scale of timber frame kit in Scotland is something that these projects are really testing and demonstrating. So Maybury is a mix of timber frame and CLT. And as just an example, this isn't off that particular school, on another school where, again, we come to the client with those choices and we say, we can look at various different life cycles with you, like Hawkins Brown and Feeling Cloud Bradley, we have our own in-house tool that actually links the RICS methodology of quantitative capital cost, as well as the energy operational energy to the embodied carbon and whole life carbon calculation. So you can get a really, really full picture. And here we're just looking at particular stages of use and the emissions. And, you know, again, backing up what we've all been saying today, you know, looking at 47% emissions reduction when you're picking and able to choose a timber frame building in relation to those upfront emissions and being aware of that. And again, you know, there is that question around sequestration and how we deal with that in the kind of whole life carbon universe, and then, you know, the longevity aspect and the area of the building life we can't control really at the end, because, you know, how many governments are going to be in play before we get to that end of that building's life. And, you know, our biggest impact is now in terms of reducing those upfront emissions. So the project is just kind of running through the design stage, and again, part of that exemplar set that's influencing public sector policy, which has been really, really exciting. And I think when we talk about whole life carbon and embodied carbon, I think it's very easy to forget that actually the operational carbon and the building performance and the building fabric is really critical to driving down those figures as well. As you know, Andrew had some amazing graphs showing that. So the Enterprise Centre for the University of East Anglia in Norwich had a really, really ambitious brief. This was back when we met the client in 2012 actually, where they had really, really high aspirations. And I don't believe that there was a building in the country at the time that was trying to hit all of these targets as part of the brief requirements. So a key one was the 100-year design life and evidencing that to them in terms of climate change adaptation as well. Pathway certification, we had BREEAM in there. I mean, you know, they really just threw the Magnificent Seven at us in relation to what they wanted to aspire and achieve to. And we'll come on to some of these aspects in a moment. Very basic, kind of simple two-story university building with a mixture of learning and teaching spaces and hub and enterprise startup spaces. So the functionality of this building was for postgraduates and business startups, as well as being a kind of central social space for the university as well. Very simple, rational section. So timber frame, very much elevations responding to our orientation and the kind of glazing, as well as the internal kind of brief requirements that we need for the building. All supplemented off a central MVHR unit. This was pre-decarbonisation, so, you know, there's a gas boiler heating this building way back when it was completed in 2015. And the other high performance fabric aspects that we have become familiar with within this body of people, group of people. And I suppose it's a little bit like Marmite. You either love or hate that we were very innovative with taking straw and patching to a new beginning on the Enterprise Centre, where we were able to format it into vertical cladding panels. And this involved the requirement to work with local supply chains. So again, a very low embodied carbon initiative and innovation, where master thatchers in Norwich and down the southwest of England, it's a dying craft. And there was a real attempt made, well, when we delivered on it, to reinvigorate that craft and use the building as an exemplar to celebrate, you know, local supply chain, local materials. And all of the materials from the buildings, the primary structure as well, all came within a 50-mile radius of the site. So again, the planning and time and the development of this project, you know, we do need at that early rebus stage to give these projects, you know, time to breathe and be constructed and kind of the concept be brought through to reality, which let some of this really innovative work happen. We also did 3 years soft landings and post-occupancy, excuse me, evaluation on the scheme as well. And I suppose a key thing for me around this was just operationally, if we just look at the graph on the left, we have, you know, our heating and our electrical and then the kind of total operational load. And what we predicted at the design stage, again, you know, we're very much about closing the performance gap. What we predicted at design stage, which was operational energy targets, and they link very much into the whole life carbon target as well, as we were saying. The third year, where we were monitoring the building, we were quite alarmed. We thought, okay, the dark yellow in 2017, why is the energy more than what we predicted at design? You know, we're surprised when this happens. This shouldn't happen in architect buildings because it doesn't. And so we went back to the client and did some more fact finding. And what came out of that was that the building was being used far more. It became a really, really popular building on site, and suddenly it was being used for graduations. more weekend lectures. They kind of had created a kind of community facility over the weekends, and the use of the building. So, you know, the brief change to the building essentially. So we were very reassured by that. We thought, right, well, it's still a very high performance building with quite low use, but now we know that the intensification of use drove that change. So, you know, a really interesting kind of lesson learned, that we need to allow for that flexibility in buildings. The graph on the right really is probably what we, you know, we're all here today about in terms of looking at that total life cycle carbon and how we compare that to a typical CIBSE university benchmark. And you can see the graph on the right over 100 years, the total life cycle carbon. So bearing in mind at this point, it's not including the TM65, you know, embodied carbon of MEP. So we just need to be mindful of that when we're looking at some of these graphs, that we're down to a reduction of almost 70%. Compared to a typical new build at that time. And this building was delivered for the median cost range per metre squared for the university at that time in 2015. So there wasn't a kind of extra over for this, even though we managed to fit in so many, you know, natural materials and had a very, you know, ambitious brief. And I think it's one of the very rare buildings in the UK that it's achieved its 6th DEC A rating in a row. So, you know, the actual in-use performance that's measured by the display energy certificate is matching the design 6 years from completion. And we're doing a check on this because I think it's probably less than 5 buildings in the UK out of, you know, the 30 million or so buildings we have that is actually achieving this. But yes, need to fact check that one. A little bit more just on how the embodied carbon is looked at. So again, we're always very transparent about what parts of the cycle we're looking at with embodied and whole life carbon, and the kind of impact of sequestration, as Andrew's mentioned, can be, you know, really, really significant. And, you know, I think when we start looking at that post-life and longevity aspect of what embodied carbon means to materials later on, we just need to be careful about how, you know, yeah, we treat timber and where timber moves to or cycles to in a circular economy. So, you know, being aware of how figures can be represented. And I think this building shows you, even, you know, with all of the low embodied measures that we managed to put into the building, we still had a residual embodied carbon footprint on the building. And now we could offset that, you know, we can try and offset that with more PVs, but I think we really need to be careful about thinking about offsetting, because the embodied carbon of PVs themselves, the minerals that are in PVs, where those minerals come from in the world, the mining that's required to create PV panels, yes, they can be cancelled out by the fact that they generate electricity, but they're not totally cancelled out. So I think, you know, we always try and be careful about how we show, you know, we're very honest about how we represent that. You know, we went for as low carbon a building as possible, but, you know, there is this residual element of embodied carbon left. And again, something that's really important to us and important for, you know, adaptability and longevity is how successful those buildings are in post-occupancy terms. So these graphs show it's the bus survey from BISRIA in terms of, you know, really stringent post-evaluation checklists that we've done on some of our projects, where you can see that we're up into the 90th percentile for overall satisfaction. And I think one of the really interesting ones is the central graph, where the green is showing that actually, you know, almost 100%, well, you know, sorry, actually a good 70+% of people felt more healthy in the building, because when we sought for feedback on that, it was actually the really good indoor air quality that people felt, and we had evidenced as well as part of that study. And then we also have, you know, comfort and productivity. People felt more productive. So there were really good soft elements of feedback that came through that bus survey. So going beyond just the construction of the building. And here's just a couple of images where we tried to allow that transparency of having the timber frame and finishes in particular. So I know Kat referred to that earlier on, around how finishes just being honest and exposed without having to add kind of additional elements to it. And a lot of this is quite a challenge in terms of the fire compliance and regulation that we have as well. But it is, you know, can be planned in. We can make timber frame buildings compliant for fire regulations. It's just common sense and attention to detail at design stage. And we can generate buildings like this that are at a median cost for, you know, that era of construction for that particular part of the country, which was really impactful. So people are always really surprised that this building could be delivered for average university costs for that time. And the straw isn't just there as some gimmick. The straw cladding also acts as part of the shading strategy. So we're looking at the west elevation here, where the deep reveals of the shading, the deep reveals of the straw cladding actually are measured and act in proportion to the width of those glass panels on that elevation. So, you know, we played with, instead of adding more kind of vertical shading reveals to try and do with shading, we just simply tried to work with the materials that we had. So again, trying to be more honest, trying to make the materials work harder for us, to create that sensitive shading strategy as well, because we need to be careful, as we've mentioned, about climate resilience going forward. The final project I wanted to talk to you about in my whistle-stop tour is that the Cambridge Institute of Sustainability Leadership. So this building is one of the largest Enerfit retrofit buildings in the UK currently, and it's about 6 months onto site, where it has, again, a very ambitious brief. So similarly to the Enterprise Centre, which was a new build, we have a very ambitious client who was looking for also a low carbon retrofit. So, you know, coming in and putting a load of PIR on the inside of the wall cladding, inside of the interior walls wasn't going to do it for them. A real consciousness around the materials and insulations that we're putting in the building was a key driver for this project. And again, it was a project that has a very ambitious brief set. So we also have the WELL building standard that we must achieve, as well as the Passive House certification as well. So you might think we might spend a lot of time trying to achieve all these standards, but you know, I think Passive House is the methodology for energy, allows us to go a great way on a lot of these journeys. So I just want to show you this graph here, which I've just pulled out. Really, I mean, I think we've talked again, when we talk about whole life carbon and embodied carbon, you know, the unregulated loads, when we look at operational carbon, is something that all of our regulations omit. So anything that talks about net zero carbon in operational terms is usually not considering unregulated electrical energy load. So we need to be really careful about accurately accommodating and accounting for that in our buildings, and we'll show you at a graph at the end to show the whole life carbon impact of that. So again, where we're trying to go from, so the meter readings on the left showed, you know, a figure of over a million kilowatt hours in relation to energy consumption, and we're trying to really drive that down. You can see the target value there for Enerfit Classic, which is where we ended up with on this building, the 60 kilowatt hours per meter squared, which is a really ambitious target with a little bit of tolerance there. And again, being very mindful, like we talk about embodied carbon, being mindful of the terminology between, you know, energy use intensity, final energy and primary energy, and delivered energy, and how we represent that across our buildings. Retrofitting buildings is really complicated. There's amazing successful examples of this in Glasgow at the moment, by Collective Architecture and John Gilbert Architects, and others on the domestic residential side. In the non-residential side, there's a lot more complexity and challenge, I suppose, in the detailing, and the roof and mansard roofs in the CISL building are definitely projects that areas that we're really focusing on. And we can see that just even from the very concept sketches we did at the very beginning, you know, the existing strategy where we had, you know, it's a listed building, the single glaze sash windows, the internal structure was quite difficult to work around in terms of circulating fresh air, etc. And what we tried to do in the proposed is address the fabric from the outside in. We have a healthy level of internal insulation there that is balancing with the hygrothermal and moisture risk requirements on the building. And we've tried to centralize the ventilation and use a kind of cascade ventilation approach in relation to distribution of fresher air, whilst addressing the thermal performance in the window zone itself as well. And this is just kind of bringing that sketch on a little bit further, where, you know, we have a really robust external envelope now with internal insulation. Lighting and services efficiencies are improved, and again, you know, we're bringing that future whole life carbon figure down and down as we start looking at this, and again, maintaining the good parts about the building, so the superstructure, the raised access floor, you know, any benefits that we can take forward that we have to work with, we're able to do so. I think that one of the main studies and main outcomes that came out of this project was that we were dealing with a listed facade and a building that had been around for, you know, 180 years already. And what we were being asked to do was to ensure that this building was going to be sufficient and robust and climate resilient for another 100 years. And a huge part of this, because a significant part of the heat loss was through the windows. And this just describes the process of how we stepped through all sorts of options with the conservation architects, with the planners, with our own client team, about how we could get to an energy efficient solution that responded to daylight, to thermal performance, but also used a minimal amount of material. So from an embodied carbon point of view, if we used a mock triple glazed sash, horizontal glazing bar window and recreated something that was in the past, but for the future, the amount of energy, process, the capital cost, the embodied cost of that was hugely significant for not much benefit. Actually, we'd lose a quality of daylighting and we'd have to put extra lighting internally to try and deal with that fallout when you start adding on the internal insulation that we were going to increase the reveals by, etc. You can see the relationship here where, we did really need to get to option 5 to get down to this energy target the client wanted. And also there was a spin-off benefit of that where the daylight factor, which was really poor in the building, was able to, increase substantially by almost 30% without compromising on any overheating risk. So there was this real kind of delicate study done to realize this. And again, it might be one of those things you think, oh, well, I'm a real conservationist. I don't believe you should have done that to the building. The special character is ruined. And to a certain degree, yes, the significance of those sash windows has been, well, removed from the building for its new life for the next 100 years. And I suppose I would counter that, the Georgian and Victorian eras treated those windows very differently through various different eras. And it's really kind of a question of what era do we want to remain stuck in. If we're dealing with a climate emergency, I think our buildings also need to evolve, as they always have been, to suit and become suitable for those challenges. And again, another impact of that was that we were able to keep and retain the brick facade, and we were able to kind of almost return to that Victorian dark void where the window is. So, kind of architecturally, it kind of gave it a different value to the building, and you can just see that value here as an example. So just coming to the end of my presentation, I appreciate, thanks everyone for hanging on. Here's a mapping of the whole life carbon over the A, B, and C cycle. So bearing in mind that, Letty and Reba, you have to read the small print about what part of the cycle that those carbon calculations are including for, which I think a lot of the industry is getting caught out with at the moment. We just need to be very careful where we're defining the boundary, as Kat said. And over 100-year life, you can see that the operational energy of this building was so much more significant than the embodied carbon because we were able to retain the existing structure. And any embodied carbon that we had added for the energy performance measure improvement is insignificant compared to the embodied, the overall operational reduction that we were able to make. And we're finding this on a lot of projects at the minute with retrofit, that actually, even though there's slightly higher embodied carbon impact on the building because you're adding some layers of materials to make it more thermally efficient, the overall operational emissions reduction, whether you look at 60-year life or 100-year life, is so significant, when we're looking at emissions on its own, that, it becomes a no-brainer. And I think as Yannick and Kit and Andrew have already expanded on, it's about trying to communicate that in the most powerful way to the client is where I think the real challenges and opportunities lay. Okay, that's all from me. I'll stop sharing and I'll hand back over to the team.
Thank you so much, Anne-Marie. If the laptop wasn't on mute just then, you would have heard a big applause. Okay, so we were going to do some Q&A, but we overran a bit, so we need to get ready for the next event in this space. So I'm just going to wrap up. But I want to thank all the speakers. So Kat, Yannick, Andrew, and Anne-Marie, fantastic presentations. Really good to see everything from the global scale, national scale, right down to what you can actually do on projects. Really, really good. We did have some really interesting questions from the chat box, so thank you for those. I think what I'll do is I'll send those out to the speakers, and if they have time to answer those, we can then send that round to everybody that logged in online. We'll try and share the presentations that people gave today as well. So thank you everyone for coming in person. It's been really good, and thank you all for coming online.